Hello everyone, today I'm going to show how to solve question 23. There are 4-point charges are brought from infinity and assembled into a group of charges. So for part A, if the charges are fixed to a straight line as shown in the diagram, what is the electric potential energy of this group? First, let's look at this picture. We can see that Q1, Q2, and Q3 are all positive charges, while Q4 is a negative charge. That means Q1, Q2, and Q3 repel each other because they are all positive charges. And Q4 is the only one being negative. It attracts all other 3 positive charges. Now let's draw the free body diagram. Because the charges are placed on a straight line. So from left to right, Q1, Q2, Q3, and Q4. We can only consider one direction, like X direction. For Q1, which is positive, it receives a repulsive force from Q2, pushing it to the left, and also a repulsive force from Q3, pushing it to the left. But for Q4, which is negative, it gives Q1 attractive force, pulling it to the right. So Q1 has 2 forces to the left and 1 to the right. Now let's look at Q2. Q2 is positive, so it receives repulsive force from Q1, pushing it to the right, and another repulsive force from Q3, pushing it to the left, and the attractive force from Q4, pulling it to the right. And for Q3, which is positive, you receive repulsive force from Q1, and Q2 pushing it to the right, and also an attractive force from Q4 pulling it to the right. So finally, let's look at Q4. Because Q4 is negative, all the 3 charges on his left is attracting. So there are attractive force from Q1, Q2, Q3, pulling it to the left. So the problem are asked for the electrical potential energy. So we can use this formula. EP equals K times Q1, Q2 over R. Now first we know that constant K is 9 times 10 power of 9. And the distance between Q1, Q2, and Q3 and Q4 are all 0.5 meter. So by taking this value into the formula and we can find out the value of 6 different electrical potential energy. And by adding them together, we can know the answer is 0.564 joules. Okay, now let's move to part B. So how much work is required to assemble the charges at the corners of a rectangle as shown in the diagram? So we can see there the 4 charges are placed at the corners of a rectangle. The charges are the same as before. And Q1 is positive 2 microcoulombs. Q2 is positive 4 microcoulombs. Q3 is positive 6 microcoulombs, and Q4 is negative 8 microcoulombs. So let's draw the free body diagram for part B. Because the charges are placed on the four corners of the rectangle Q1, Q2, Q4. So there will be multiple directions. We know the distance between Q1 and Q2 are 0.25 meter, and the distance between Q2 and Q3 is 0.5 meter. So for Q1, which is positive, it receives a repulsive force from Q2 pushing it upward. And it also receives a repulsive force from Q3 along the diagonal direction, pushing it up and left. And for Q4, it attracts Q1, pulling it to the right. And for Q2, which is positive, it receives a repulsive force from Q3, pushing it to the left, and a repulsive force from Q1, pushing it downward. Also, an attractive force from Q4 along the diagonal direction, pulling it to the up and right. And for Q3, which is positive, it receives repulsive force from Q1 along diagonal direction, pushing it to the downward and right. And two repulsive force, one from Q2 pushing it to the right, and another and an attractive force from Q4 pushing it upward. So for Q4, all three other charges are attracting it. So it has three attractive forces, one pulling it to the right, and another pulling it downward, and the third pulling it along the diagonal line to the down and the left. So we need to find out the diagonal distance. So because it's a rectangle shape, we can use root 0.5 square plus 0.25 square to find out the diagonal distance. And the square root is approximately 0.559 meter. And now we can calculate the electrical potential energy for this rectangle. So we are using the same formula. And by adding all the six electrical potential energy together, the sum is 1.618 joules. Because it's energy, so we can remove the negative sign. So the final answer is 1.618 joules.